All right, aloha everyone. This is Anthony Wright, and with my student volunteer and his mother, Kai and Michaela, we are going to be given a demonstrating with an example of the Common Core state standards for math to compute fluently with multi-digit numbers and find common factors and multiples. The standard for this is to fluently divide multi-digit numbers using the standard algorithm. So we'll take a look at the standard algorithm, and we'll also take a take a look at other ways to solve problems. Just kind of taking a look outside of the box. So I'm going to go ahead and share my screen, and we're going to start with a video of it's a video that is showing from someone your age, that has troubles with math. It can be a little discouraging at times, but I think this video does a good job at showing how math can also have positive benefits. So let's take a look.
How do you feel about math?
I'm not good at math.
I just don't get it.
It makes me kind of feel uncomfortable.
When I get called on in math class, I feel scared.
Because I'm afraid I'm gonna mess up the problem.
My brain just doesn't think anymore, doesn't think straight, and I just go like, okay, what do I do? I have no idea what to do.
Math makes me feel stupid.
Scared that I would answer wrong or get laughed at.
I'll never be able to do this.
Scene 16, take one, marker.
I'm still learning who I am.
What I'm good at.
Forming my idea
Of my own potential.
And if I think I can't be good at math, I won't be.
But math is everywhere.
Math is a basic life skill.
Without math, I could get left behind.
So help me know that limits don't exist.
That math isn't beyond my reach.
that my potential can take me anywhere.
That with hard work and the right mindset,
I can grow.
Because math esteem is self-esteem.
With math, I can be a fashion designer,
A doctor.
A computer programmer.
a wildlife biologist.
A teacher.
With math, I can be anything.
So click the link,
Take the pledge
And find out how you can implement
growth mindset strategies
to improve your students' math esteem.
So I can have a fighting chance.
to become who I want to be.
All right. So with that video, we're reminded of a growth mindset. Now, with the growth mindset, you want to remember that the mind, the brain, is a growing organ. So the more you think, the more powerful your brain becomes. So it's very important to just remember that all you have to do is just simply take that first step. All you have to do is just simply try, and you will learn. So we're going to take a look first at the standard solving a long division problem with the standard algorithm, and then we'll try a few examples. So let's share the screen one more time, and we're going to go to another video here.
Hi.
You may need
this
to
video
adjust
is
your
going to
volume.
Go over one problem that uses the Common Core strategy of partial quotients when we're doing long division. And if you didn't grow up with Common Core, or if you absolutely hate it, then you'll probably get annoyed with this strategy. But if you are at all open to the possibility of seeing a different way of doing something, then I think that this strategy is actually really cool, and it allows you to successfully do long division in an easier way where you're using really easy numbers to break apart that sometimes gigantic dividend. So we'll just go through an example. You can pause it, fast forward, try it out on your own. But the idea behind it is that in traditional long division, you would take this number and you would say, how many times can I fit it into my dividend? So how many times can 32 fit into 145? And usually in a traditional way, you're doing estimating, or you're guessing and checking until you find nearly an exact number that you can put as you work digit by digit through your problem. With partial quotients, you're kind of doing the same thing, but you're doing it in chunks with easier numbers. So what we will do, if you're first starting out, you want to keep it super organized. So it's a few extra steps, a few extra things to write, but then you can skip all of that and do most of it in your head. So the idea is that we do our work down the side. And we're going to say, what chunk can we multiply 32 by to get close to this number? And I'm going to start with 10s. You can do 20s, 30s, 2 if you want. But 10s are an easy number that you can really quickly work with. So I'll say 10. So you do 10 times 32 is 320. So you take that number and you drop it here. And just like regular division, you would subtract. And you have a new remainder. And then you do the steps again. So you say, what can I multiply times 32 to get me close to this? And so I can use 10 again if I want. So I'll use 10. 10 times 32 is 320. Do my subtraction. And I have a new remainder. And then I'll do it again, because I can keep breaking this down into a smaller chunk. So what times 32 can get me close to 810? Well, I can use 10 again. So 10 times 32, 320. And I have another remainder, so I'll do it again. But each time that I'm doing it, these are really easy mental math numbers that I can be using. So I'm not calculating big things on this.
Okay, so I'm just going to pause it there and just go over what she was talking about. So as you see, 10 is a really easy multiple to use for 32. Once you start figuring out that it's going to take a whole lot more than your initial estimate, you can double that. So you can see if you just simply add those two together, you're going to have 640. So for the next time, you can put down 20 times 32 and have a bigger estimate. So you're not constantly having to go through multiple steps. But we'll just go ahead and continue on with that video.
So I can do something times 32 again. And I will use 10. 10 times 32 is 320. Do my subtraction. And I get 170. And now I have to pause because I've been using 320, but that's too big to get down to 170. So I need to use a different number. So maybe I'll multiply by 5 or by 2 or something. So I can do, let's try 5. So if I want to do a little scratch area on the side, I can if I want to. 32 times 5 is 160. You can do that in your head if you want, but 160 works. So I will use 5. And I have my work here, so that's 160. Do my subtraction, and I get left with 10. So this last number is my remainder. I can't do anything else with it because 32 is too big. So that's my remainder. And then what I do is I'm going to add up all of these partial quotients because these are basically the numbers that I am multiplying by to get here. But instead of writing it digit by digit exactly as I go along, I've broken it down into chunks. So my last step is to add them all together. So 10, 20, 30, 40, 45, and then remainder 10. So my answer would be 45, remainder 10. The way that I would check that if I wanted to go back and make absolutely sure that I did it right is I would take 45 times 32, and then I would add in my 10 to find out that it would be my dividend. So if you're not familiar with Common Core, again, this seems like a lot of extra work and it's not necessary, but if you're just starting out with long division and you're still working on math facts, then this is a way to successfully accomplish long division, just in different steps where you're breaking it into chunks. So all you need to keep track of, or what you really need to keep track of, is what you're using each time as your partial quotient. So I like the idea of underlining it, doing a little bit of extra work to write more things out because then you keep it super organized. As you get used to this, you don't have to put this times 32, you can just put your partial quotient here. Sometimes you can combine it, so if you want to start out by doing 20, that's fine if you're good with your 20s. If you're not comfortable with 10 and you want to do 2, that's fine also. You'll just probably end up using the whole page, but that's really the great thing about it is you can't really go wrong if you underestimate because you can just do an extra step and an extra step. And as you get used to what the numbers are and how big they are, then you can shorten this up by using like 20 or 30 to start with. So that is partial quotients with a the Common Core strategy. Thanks for watching.
Okay, so with that, we'll go ahead and take a break and just work on a random problem. How are you feeling about scaffolding or partial quotients? Are you feeling comfortable? You kind of get the idea of it?
Yeah, I definitely understand how it works.
Okay. Just really quick on your notebook paper, give me a 2-digit number that you're gonna sorry, a 4-digit number that you're gonna divide by a 2-digit number.
Okay.
All right, so we've got 31 divided by 5732. Okay. Let's go ahead and
Do you mean 5732 divided by 31?
or yeah, I'm sorry, 5,732 divided by 31. Thank you, sir. See, that's why you're here, to keep me on track, make sure we're learning properly. Because teachers, you know, sometimes do make mistakes too. So keep us on track. All right. So for partial quotients, how would you go about the first step there? How many times do you want to multiply 31 to get a rough estimate? Do you want to?
This is a pretty high one, so I'm gonna say multiply it by 100 first.
Okay.
Because that would give us 3,100 or 3,100, which is less than 5,732. So
Okay. So if you want to write that down and then subtract the 3,100. Okay, and your answers so far? 2632. Okay. And for this next step, how many are you going to go into for 31? Can't do another 100.
I'll have to do some real math. I'm gonna multiply it by.
Well, if you just simply take half of that 100.
Yes, exactly.
You
That's
have,
what I was thinking. 50. So we could take 50 because it's around 1,500. So
what's half of 3,100?
half of 3,100. Oh,
Half of
half of 3,100 would be 1550.
Correct. 1550. So where are you at so far?
I am at 1,082.
All right, correct. So we're dwindling it down. What's a number that we can get close to 1,082?
We'll multiply it by 10.
Okay.
And that would be 30. That'd be 310.
You can do it between us.
772.
Correct. Okay. So just go ahead and work down the line, and we'll see what your answer came out to. Go ahead and continue with that scaffolding process, and just show all your steps, and we'll see what you came out to.
It would just be double the time.
Oh no, I know. I'm just gonna make sure.
It would just be double.
I can't help myself.
No,
I have
you
to.
already know what it is. It's so easy because it's double that.
I know. Okay. Yeah. but I have to see what it actually equals. So.
One.
Okay. So should we finish it? Like add all the partial quotients?
Yep, add all your partial quotients together, and then if you have a remainder, go ahead and show that as well.
All right.
I got 184.
Yep.
There you go.
Yeah.
With the remainder of 28.
All right. We've got our answer.
Okay.
We got 184 with a remainder of 10.
Remainder of 10.
Sorry, I meant with a remainder of 28. With a remainder of 28.
Thank you, Professor. That is correct. Elementary, my sir. Okay, so let's go ahead and review one more quick video because I want to show you a great way to do area models or breaking it down into the place values. So here we go. You might need to adjust your sound again. I think this one's a little louder.
G'day, I'm James, and today I'd like to talk about long division and try to see what's really going on with the whole story of long division. In fact, I kind of mean that literally, to see what's going on with that story. Now, many people like to think of division as the reverse of multiplication. So just to get us going, let me do a quick multiplication problem and start drawing pictures for that, and then see if we can start undoing those pictures for the fun of it. In fact, here goes. Let me try 1,302 times 3. Why not? Actually, I can see what the answer is going to be to that one. That's actually going to be 3,906. Okay, grand. But what's the picture to go with this? Well, I just said a lot of words there, 1,302. I'm speaking base 10, so I can represent this number in a place value chart where we have the ones, the tens, and the hundreds. The ones, the tens, the hundreds, thousands, I guess I need those. If I want to go further, 10,000s, and all the rest. Now, people who know me know I'd call that a 10-1 machine, but it's just really a place value chart. And when I say a number like 1,302, I'm literally saying one of these, 1,000. 300, three of these, 300s. I didn't mention any 10s, and two units, 2 ones. Great. And in this multiplication problem.
Okay, really quick, is that making sense to you as far as the number of place values? You have the ones place, the tens place, the 100s, 1,000?
Yes.
Okay.
Problem being asked, please do that to it. Please triple everything. Please triple what you've got. Oh, I'm going to literally do that. I'm going to triple what I see. There's one dot. I'm being asked to triple. I'm going to triple the dot and make it 3 dots. There's another dot. I'm going to triple it and make it 3 dots. There's a dot. I'm going to triple it and make it 3 dots. There's a dot. I'm going to triple it and make it 3 dots. There's yet another dot. I'm going to triple it and make it 3. Another dot. Triple it and make it 3. So now I've got 3 dots in the thousands place, 9 dots in the hundreds place, none in the tens place, and 6 in the ones place. Oh, I see the number 3,906. There it is. I literally see it. All right, so now, can we actually take this process? Oh, it's already tripled. Don't need that word anymore. It's done. Can I take that process and do it backwards? Suppose you didn't see the question. All you saw was the answer. Could I undo this? In fact, let me do it over here. Let me draw the answer. Let me draw the answer of 3,906. Here it is again. It's 3 dots, 9 dots, and no dots, and 6 dots. Here they are. And let me see if I can undo that multiplication. That can be expressed as this problem. 3,906 divided by 3. What got tripled to give the answer 3,906? So I'm doing like the reverse multiplication thinking here. All right, well actually, that kind of thinking is great for this problem because look, I'm asking what got tripled to give me this answer. And I look at the picture and say, oh, well, hang on. There is a group of 3 dots. There must have been 1 dot there that got tripled. In fact, there's a group of 3 dots. There must have been 1 dot there that got tripled. And this must have been a dot that got tripled. Another one there. And that's a dot that must have been tripled. Another one there. No dots there got tripled, but a dot here got tripled, and another dot there got tripled. So actually I can see that 1 dot at the thousands level, and 3 dots at the hundreds level, and 2 dots at the units level got tripled. I can see, oh, it must have been 1, 3, 0, 2 they got tripled. Aha! So I kind of undid this. I love it. That's division. Now, of course, a lot of people like to think of division as groups of, like how many 3s can go into 3,906. And I'm actually seeing that too. I'm seeing 1 group of 3 at the thousands level. I'm seeing 3 groups of 3 at the hundreds level, and 2 groups of 3 at the units level. I'm seeing 1,302 groups of 3 in that picture. So in the groups of thinking, I'm also seeing it there. Wow. This is actually lovely. This is visual. This is beautiful. This feels like conceptual depth to me. So let's just practice this some more, and let's do another example. I'll keep it straightforward right now, and let's do something like, I don't know, 426 divided by 2. What got doubled to give the answer 426? The answer is 213. I can see that, but in my mind I can see that, but I want to literally now see it with my eyes. Can we actually see the answer 213? What got doubled to make 4 and 2 and 6? So now I'm looking for doubles. What got doubled? Well, here's a dot that got doubled, 1 there. Here's a dot that got doubled, 1 there. Here's a dot that got doubled, 1 there. Here's a dot that got doubled, another one and another one. 3 dots there got tripled. Indeed. 2 at the hundreds level, 1 at the tens level, 3 at the units level got doubled to give that picture of 426. Beautiful. Now, there can be a snafu, and let's see a snafu in an example like this one. 416 divided by 4. Again, I can tell what the answer is going to be. It's going to be, what, 104? Okay, but let's see if we can see what's going on. So this time it's 416, 400, and 1t6. See, this English is weird. We don't actually say 110 and 6. We say 16 all of a sudden. Curious. And now looking for groups of 4. Just to be really clear, 4 is literally 4 dots in a box. And I see that in only a couple of places. There's a dot that got quadrupled, 1 at the hundreds level. And there's a dot here that got quadrupled, 1 at the units level. And that's all I'm actually seeing right now. And it's got me a little bit nervous. I've got a queasy feeling in my tummy. Surely there should be more in there. In fact, I know the answer is meant to be 104, not 101. What's missing? What can I do? Plus I've got this random stuff left over. It feels incomplete. It's all jarry. This is the lovely thing about math class, because you've got these human emotional reactions to these things, and they're legitimate, that have a human experience with maths. And then see if you can take a deep breath and do something. What clever thing could we do to push this forward some more? And then you realize, how does place value work? Well, we've always said that 10 ones make 10, and 10 tens make 100, and 10 hundreds make 1,000. The reverse would be 1,000 is really 10 of these, and 100 is really 10 of these, and one of these, 110, is really 10 of these, 10 ones. Let's use that to our advantage. This dot here is really 10 ones. Let me draw in 10 ones. The reason I'm doing that, because look at this, it's showing me loads more groups of 4. That was 10 of them. Yes, 10 of them. Great. 10 ones, because look, there's another group of 4. There's a dot that must have been quadrupled. There's a dot that must have been quadrupled. And there is a dot that must have been quadrupled. And indeed, that's all the dots. And I see the answer is 104 is what got quadrupled. Whoa, so this idea...
Are you following? Yeah. Everyone with me? Okay.
Undoing a dot. I call it unexploding in my exploding dot story. I think the curriculum calls it borrowing or regrouping or ungrouping, some words like this. Whatever it is, the visual is make 110 back to being 10 ones to see more groups. Very, very handy. In fact, it's particularly handy when it comes to doing multi-digit division. So let's go up a notch in difficulty. Let's do something like 276 divided by 12. So start by drawing a picture of 276, 2 hundreds, 7 tens, and 6, beautiful, and 12. 12 is going to be sneaky, because technically 12 should be 12 dots in a box. Except society doesn't allow me to have 12 dots in a box. They always want me to regroup tens. So this is actually, think about this. 12 dots in a box. There's a group of 10. If 10 ones really makes 110 and leave 2 behind. That's annoying. All 12 dots are really there, but carrying pushes one over to the left. Or in my language, exploding pushes one over to the left. So to keep in mind, what 12 looks like is one.
So just to reiterate, you know, for place value, the maximum place value in base 10, which is our standard number system, is 9. You get up to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you get 2 digits. You get 1 to start it all over again. And then from 10 all the way up to 99, 100. So there you have your the reason for these dots in separate boxes, because there you have your 1s, your 10s, and 100s place.
1 dot next to 2 dots, but all 12 dots are really in the most part of that picture. So 12, do we see any 12s in 276? What got multiplied by 12 to get this picture? So we're looking for 1 dot next to 2 dots. And do I see any 1 dot next to 2 dots? Why, yes, there's 1 dot next to 2 dots right there. Now let's be really clear, in that pink loop, where are those 12 dots really? They all must have been here on the right part of the loop, and then kaboom, 10 of them explode to make the next one place over. So all 12 dots were really there at that level. So there was 1 dot there that got multiplied by 12, and spillage pushed one over to the left. In fact, there's another 1 dot next to 2 dots. And again, all 12 dots must have been in the right part of that loop, and boom, spilled over. So there's another dot there that got multiplied by 12. Any other 1 dots next to 2 dots? Well, yes, if you shift over 1 spot to here, there must have been 12 dots there. Kaboom, and spilled over. There must have been 1 group of 12 there. And again, there's 1 underneath that. 1 dot next to 2 dots. Right there. And actually, my loops are getting weird, but there's another 1 dot next to 2 dots. Right there. All 12 dots must have been here, and kaboom, spilled over. So actually, I see the answer is 2 at the 10s level, 3 at the 1s level. The answer is 23, which I happen to know is correct. Wow, I'm seeing multi-digit division.
All right, so let's go ahead and try to practice that. How are you feeling as far as comprehending what that instructor was showing us? Is it making sense to you?
Understood everything, and it all made sense to me.
Okay, so you have the link that I posted in the chat. Go ahead and click on that link and share your screen, and we'll see if we can't solve that problem. All right, so you see the key up in the top. You have, just like in the video, the group of 12, it'll be 2 in the 1s place and 1 dot in the 10s position. So go ahead and try to group that up and see if you can figure out the answer. So you'll, starting from the left, you need 2 boxes with 1 dot and 2 dots. If you see that, go ahead and circle it. Oh, no, that's just the key.
Oh, sorry. Okay, so.
All right, so as you hear, that duck right there is getting to be time to spread your wings and enjoy the rest of your day. But before you fly away, I just want to review. So we did kind of run out of time before we got to work on this problem, but I'm going to send you home with an assignment. We're going to review scaffolding or the use of partial quotients, and you're also going to work on area models. So I sent a link to your email for the homework assignment, and with our next class period, you're gonna share your work. So great work for today. And any questions before we go?
Oh, thank you.
Nope. Oh, yeah, just one question.
Ask away.
Bathroom, please.
Well, it's the end of the class, so just make sure you're on time for your next class. Aloha.